Hello YouTube, today is a little bit different because I want to do some theory about this guy here. You know from the previous video, as I done a voltage doubler, and I got some questions about it regarding how it works and some like. And I decided to do a little theory video about this one here. I haven't done something like this before, so I hope you will understand it. I will do my very best to explain it. Okay, let's see. This was the input of the whole thing, and this is the output. And I will do a little drawing of this one. Okay, we got a transformer here. And a secondary coil. And let's do a proper drawing of this one. So I think this is the best way. And the other one. Yep. Here we go. So, and this is the positive. Yeah. And this one is the negative one as well. And this is so, and in between here is the output. So, hope you can see this. I'm not sure. I checked the video, maybe I need to do it again. So anyway, let's see. Let us call this voltage here the secondary output voltage, U sec, and this is U out. In Germany use the U for instead of V. The UK guys use the V letter for voltage. We use the U letter for voltage. Someday long ago I know where it comes from. No, I don't care about it anyway. So this is negative, this is positive. As they are polarized, it's better to put it the right way, otherwise they blow up. So, okay. I do a little drawing about sec voltage. Something shitty. this is the time axis and this is the voltage axis. Okay, as we have AC voltage, it has to be minus and positive. So let's see, let's draw a proper sinusoidal waveform, huh? Do here, dreimal, 3 times here, 3 times, 3 here and here, so here. Alright, 3, yeah, should go. Not properly sinusoidal. Sorry for this, but I think you get the idea what I'm doing here. So anyway, this is more triangle-ish, but who cares? So this is this voltage here, and now we need to do the output as well. Output is just positive with respect. So ground. So okay, this is out. So okay, first we do some color, huh? Colors may help a little. No, this is maybe too light. So okay, first we start with this section here. That's the green one. Here we go, the green one representing here positive and here negative. Okay, what happened inside the circuit with respect to this output here, otherwise it don't make any sense, is as follows. As long we are on the rising edge of this diode conducts and load this capacitor. So this is identical. Let's see. We start and do the same over here. I have to do the same. This is only 1, 2, 3, 4. 1, 2, 3, 4. That's why I use these guys to draw something. 1, 2, 3, 4. 1, 2, 3, 4. This is topmost. So, and 3 over here gives us the peak over here. Yeah, am I right? You. Good. So, here's the peak. What is happening now? This is fully at the same potential as this. These are now together at this point. So, okay, now we have to discuss the negative. For the negative we need to have a we get a blue one here. This is here the blue one. So here we go. Yeah, blue is cool. So right now this is open because this diode now is in reverse, as we have now the minus over here and the positive rail, because it's switched, because we got the AC voltage here and therefore AC current, and therefore this is open. Okay, this is not inside, and conducting diode is this one. What we now got here, here's positive, current flows here and loads this capacitance. What's happening now is we rise, or we got some new voltage over here, like this, with respect, like this. We have the positive over here and the negative over here. And now we got the current flowing here, and this is loading this capacitor. Let me see, we need this point here. We do it like this, and it holds the voltage until this and here. So, assuming here's no load. This is a little bit different when you load the circuit, because we got a falling edge here. So, and this is the section here. So why I do this? It makes no sense until here, because this is alternating current. You're familiar with this? Alternating voltage, alternating current. And what's this? It looks the same, but it isn't. Trust me, because it doesn't make any sense at the first place. But when I continue with my drawings, and I need to extend this axis here, maybe this length and this as well, same length, need to be, here's something underneath, sorry about this, normally my drawings are a little bit better. Yeah, it's the next, here's the next, here's next, and here's next. So the same over here. 1, 2, 3. Yeah, am I right? Yep. Still track here. And over here need to be at the same positions, otherwise we are going off track. Okay, let's do at least a little bit sinusoidal. Here we go, we got the maximum over here. Am I right? So, now here comes the funny part. This is green again. There we go. And this is blue as well. There we go. Yeah. And this is green as well. So now what's happening is, if there is no load, we can, this is charged upon doesn't draw any current anyhow. This will stay as this. Okay, now we got some, yeah, extend this until this position here, huh? Here we go, yeah. So, okay. Shutting down this. This is this diode. Will be shutting down rapidly over here with a little bit overshooting, I think. That's what I saw on the DSO. It looked like some peaks over here, and the peak was this one here, this one here, and the next. Good. Anyway, now we got this. No, black one first. So no current flows as we got no load. Stays here. And now we got this. Oh, we got the spike here and no crossing, no zero crossing. It's just a little help from here we go. This is the blue section. I think now you got the idea, because why this is a voltage doubler or acts like a voltage doubler. This stays. So, what voltage we got between here and here? Here's negative and here is positive. As I assuming we got here about, let's say, 1 volt, huh? This should be sinusoidal, okay? Let's assume this is sinusoidal, not as I draw it. More round here, and this is like this. I think you should excuse my poor drawings here, but it's easier to assume this is all sinusoidal, and we got 1 volt this. Okay, we got here the peak to peak voltage of 1.1 volts. So, and we got here as well minus 1.141 volts. Peak. Okay. And now we got here, over here, the same with respect to the voltage drop here. Okay, to I get at least 10 watts, huh? Make it easier. Let's do 10 watts. This is not quite 11. No, it's not right. Let's see what it is. 14, no. 14. 14. 14, no. 14. So this is the same. 14. this wasn't right anyhow. So okay. Now we got here 14 something. Well, 13. More practical. So, and this is 13 something because we got a 0.5 to 0.7 volts drop here. You know, you have to subtract. You have to subtract the voltage drop of the diode. At least a little more. Okay, but I think you got the idea. We got now about between this one and this one round about 26 volts. Total voltage. And this is how it works. And to get rid of the ripples and whatever, you need to do a proper filtering of this one, because this whole time here, the time where this cap is discharged, it is much longer than with the usual rectifiers, as the caps here are fully charged here for the positive and this for the negative. We got really double the voltage, because this is the maximum peak where you can charge this cap, and this is the maximum peak where you charge this cap here. So we got, if we got 10 watts RMS sinusoidal, sorry for my poor drawings here, we got 10 RMS sinusoidal, we got the peak of 14.14 volts positive and the peak of 14.14 volts, 14.14 volts, sorry, from this here, the minimum voltage peak. And as we add two capacitors here, the capacitor here hold the charge until he's charged from the next positive, and this capacitor here will hold the charge until we got the next charging. You end up with, you know, you got a voltage drop from the diodes here about 0.5 to 0.7 volts. We got a little voltage drop. It's about, I rounded it to 13 volts and 13 volts to make things easier, and we got a total voltage of 26 volts DC. But you need to keep in mind that when you power this from the mains AC, here in Germany we got 50 Hertz, and you in the US you got 60 Hertz, slightly better. But you need to keep in mind that this charging frequency drops to 25 Hertz or respect to US 30 Hertz and 25 Hertz for this capacitor. Therefore you have the charging frequency with respect to the normal rectifier. single rectifier circuit. So you need to double this capacitors. And you need to have another capacitor over here inside to prevent the discharge here to the discharging gap too much, because when you draw here some current out of this point, you know, it's gonna happen like I made it a little bit extreme, maybe this and over here as well, and like this as well. So you need to have a much higher capacitor in this here to prevent the discharging here, because these capacitors don't help you as much as you double the voltage here to get double the ripple as well, and therefore you need to have a very high filter capacitor inside. But as I run this here from about 50 kilohertz, you end up with a lot more charging than it would be when you power it from the mains. Therefore you can have here very little capacitors. This is one of the benefits when you use a switch mode power supply. You use a switch mode power supply instead of the mains for mains transformer here. In my case here, in my little tube amp, I use the switch mode power supply. It operates between 30 and 60 something kilohertz depending on the load. Therefore you need to have some other type of capacitors and as well diodes, because if you have inside here, let's assume you got a 1N4007, it will simply heats up and blow because of the reverse current, because the 1N4007 is not fast enough to operate at 30 something kilohertz, and these peaks here will be much higher and have much more current when you use this diode here. It will be looks like something about this, and here as well, and you see this is reverse current. It's maybe as high as here. This is not voltage, this is I draw current here. Sorry about this mixture here. It should be like this, so, and here as well, and this is a little I, because this is momentarily current. So this destroys the 1N4007 within a minute or so due to overheating from the reverse current. And therefore you need to have it's the same, but it's called UF ultra fast, with the same maximum voltage and current. It also can be used for 1000 volts with this and 1 ampere maximum. But you still got these spikes here, but very thin spikes. So keep that in mind when you power those things from a switch mode power supply. You need to use fast diodes and low ESR capacitors, otherwise the whole thing won't work properly. You end up with excess heat and maybe blowing your diodes and blowing your SMPS as well, because when you draw here about 4 to 10 amps, because this is shorted here, then the switch mode power supply won't be capable of delivering such high current and blow away as well. So hope you enjoyed it. At least you got the idea what this is all about. And keep in mind you need to have a extra filter capacitor over here to get rid of these ripples when you draw some current out of this. But as you got 30 something kilohertz to 40 or 50, 60 something kilohertz, this is very narrow and you can keep the capacitor small with respect to the mains. From my practical operations or tests, I end up with something about 47 microfarads for the caps here to prevent the diodes from breaking down, and I add a little resistance here in series, this one here, and I add a capacitor between here and here from about this was test capacitors which I have lying around. It's much too high. Its readings are 680 microfarads, rated 400 volts to have something. I end up with a filter cap about 220 microfarads and 240 volts. Because I measured here peak voltage, this now I measured here peak voltage from 130 volts peak to peak with no load, so 250 volts should do very well. Okay, that is it for now. I checked the video, hope you see something here, or next time I have to choose a different angle for my video cam. Anyway, thank you YouTube, hope you understand my first theory explaining about electronics. Anyway, leave some comments inside to help me to do it better next time. Bye bye YouTube.